Fingerprint scanners are everywhere these days, from smartphones to security systems. But how exactly do they work, and can they be fooled? Let's dive in. At the core, fingerprint scanners rely on the unique patterns of ridges and valleys on a person's fingertip. Each fingerprint is distinct, even among identical twins. When a finger is placed on a scanner, it captures an image of the fingerprint using various technologies. There are two main types of fingerprint scanners, optical and capacitive. Optical scanners use light to capture an image of the fingerprint. They shine a light on the finger and take a picture of the pattern. This method is relatively straightforward but can be affected by dirt or moisture on the finger. Capacitive scanners, on the other hand, use electrical currents to map the fingerprint. They have a grid of tiny sensors that detect the differences in electrical charge between the ridges and valleys of the fingerprint. This method is more secure and less susceptible to environmental factors. Once the scanner captures the fingerprint, it converts the image into a digital template. This template is a mathematical representation of the fingerprint, focusing on specific features like ridge endings and bifurcations. The scanner then compares this template to stored fingerprints in its database. But can these scanners be fooled? The short answer is yes, but it's not as easy as it sounds. Some hackers have attempted to create fake fingerprints using materials like gelatin or silicone. These replicas can sometimes trick optical scanners, especially older models. However, most modern scanners, especially capacitive ones, have advanced algorithms that can detect fake fingerprints. Another method of fooling a scanner involves using a high-resolution image of a fingerprint. This image can be printed on a transparent sheet and placed over a finger. While this might work on some optical scanners, it's less effective on capacitive ones, which require the actual ridges and valleys to create an accurate reading. In response to these vulnerabilities, manufacturers have developed more sophisticated biometric systems. Some scanners now incorporate additional features like liveness detection. This technology checks for signs of life, such as temperature or blood flow, to ensure that the fingerprint being scanned is from a living person. Moreover, multi-factor authentication is becoming more common. This method combines fingerprint scanning with other forms of identification, like facial recognition or a PIN. By requiring multiple forms of verification, the chances of unauthorized access are significantly reduced. Despite the potential for being fooled, fingerprint scanners are generally considered secure. They offer a level of convenience and speed that traditional passwords can't match. However, no system is foolproof. Users are encouraged to remain vigilant and use additional security measures when necessary. In conclusion, fingerprint scanners work by capturing the unique patterns of a person's fingerprint and converting them into a digital template. While they can be fooled under certain circumstances, advancements in technology continue to enhance their security. As biometric systems evolve, they promise to provide even greater protection against unauthorized access, making them a reliable choice for personal and professional use.